Have you ever wondered how skyscrapers withstand earthquakes, how bridges stay strong after years of traffic, or why your home doesn't collapse in a storm? Engineers and other professionals put a lot of thought and effort into ensuring structures are safe. They use a variety of methods to assess, improve, and maintain safety, combining science, technology, and a little creativity. Let's dive into how they do it. Before a structure is built, or even after it's been standing for years, engineers assess its safety. One common method is structural analysis, where they calculate how forces like weight, wind, and vibrations will affect the structure. Computer simulations are often used to predict how a building or bridge will handle real-world conditions. For example, engineers might simulate the effects of an earthquake on a skyscraper to identify weak points. Another important tool is inspection. This involves checking for cracks, rust, or other signs of wear and tear that could weaken a structure. For example, inspectors regularly examine bridges for corrosion or fatigue in the metal components. They might use advanced tools like ultrasound scanners to detect hidden flaws, or drones to inspect hard-to-reach areas like tall towers or undersides of bridges. Once engineers identify potential issues, they work on improving safety. One way they do this is by reinforcing the structure. For instance, adding steel supports to a building can strengthen it against earthquakes, while installing cables on a suspension bridge can help distribute forces more evenly. Another method is retrofitting, which involves upgrading older structures to meet modern safety standards. For example, many older buildings in earthquake-prone areas have been retrofitted with flexible materials that absorb shocks, preventing the building from collapsing. Bridges, too, are often retrofitted with stronger joints or weather-resistant materials to handle increased traffic and harsher environmental conditions. Design improvements also play a big role. Engineers use advanced materials like carbon fiber, which is both strong and lightweight, to make structures safer. They might also design energy-dissipating systems, like dampers, to absorb vibrations from earthquakes or strong winds. For example, the Taipei 101 skyscraper in Taiwan has a massive steel pendulum inside that sways to counteract the movement of the building during typhoons or earthquakes. Even the best-built structures need regular maintenance to stay safe. This can include cleaning, painting, or replacing worn-out parts. For example, metal parts on bridges are often coated with anti-rust paint to prevent corrosion, while cracked concrete can be repaired with sealants or replaced altogether. Routine maintenance also includes monitoring systems that provide real-time data about the structure's condition. Modern bridges and skyscrapers often have built-in sensors that measure stress, strain, or even tiny shifts in the foundation. If something goes wrong, these systems send alerts so engineers can address the issue before it becomes dangerous. Finally, engineers conduct regular load testing, where they apply pressure or weight to a structure to ensure it can still handle its intended load. For example, bridges might be tested with heavy trucks to confirm they can carry traffic safely. By combining thorough assessment, thoughtful improvements, and regular maintenance, engineers and other professionals keep structures safe and sound. These methods ensure that the places we live, work, and travel through remain reliable, even in the face of natural disasters, time, and everyday wear and tear.